So here at Xenon. So who are you?
My name is Lou Panico. I'm CEO of Xenon Corporation.
So what does Xenon do?
We manufacture high-intensity pulse light systems. There are two ways to generate light in the universe. One is continuous like the sun, and the other is pulse like the lightning bolt. We're sort of the lightning bolt, a lot of energy very fast.
So a lot of energy, very short.
Very short
What does
time.
it do?
In the case of printed electronics, what it does is it sinters the ink that's printed on the film and actually makes electronic circuits, and much similar to the way that they make newspapers.
All right, so it's kind of like printing ink on paper, but it's what is printed electronics? How does it work?
It's a very, very good question. I don't know if you've ever seen a printing press making newspaper, but these giant rolls moving at very high speeds and printing newspaper information. But now what they want to do is print electronic circuits in the same way. And this allows the pricing for the electronic circuits to come down so far that it opens up new and exciting markets.
So we're talking about 100x cheaper electronics? What are we talking about?
Yes, exactly. In fact, you know, when the transistor was invented, everybody thought it was the big market was going to be to replace vacuum tubes. But when the transistor got in production, whole new markets opened up, like the computers, for example. And that's what's envisioned here, a huge potential upside to the printed electronics market.
So like they print a few million newspapers every day.
Right.
You could be printing a few million PCBs for what? Where does it go?
Well, one of the big applications is for sensors. And sensors is a rapidly growing market, for example, for wearable clothing, or wearable electronics to identify what's going on with the health of the body, or monitoring, tracking every food process from the growth area to the supermarkets.
So basically in an area like here, we'd like to have sensors everywhere, in the floor, in the walls, everywhere.
Right.
It's the only way to do it, right?
Right. Well, that's an interesting application. And then they shut down the auditorium at night, and they can easily find out if someone's walking around, and they know where they were.
And know who's where, because I'm walking around the conference, I can't find the different guys, and you need to know exactly where they are inside the room.
Right, and you can do that on your iPhone.
With their permission.
Right, exactly.
So this is one of the products?
This is what's used to actually make the electronic circuits.
So this is your product?
Yes, this is a high-intensity pulse light lamp. It is put over the conveyor line, production line. And it pulses light.
Is this is this where it is?
This video explains the process, yes.
So
it's actually printing a circuit. See the circuit there?
Yeah.
Now, just imagine in the food industry, you buy some food in the supermarket and something's happened to it where it doesn't taste right. Okay, and everybody's familiar with that. But if they have these sensors on the food from the growth area all the way through the system, it'll tell when some food product got more heat than it should have gotten and cause it to have a shorter shelf life. A huge amount of information, billions and trillions of these sensors need to be made.
And what are we looking at here? Can you hold it up?
This is a circuit. Okay?
This is a circuit.
Right.
So this kind of
printed on plastic.
This kind of
very interesting.
This kind of circuit. How long has this existed? Since when have we had something like this? Prototypes. How long has it been in development?
It's been around for maybe 10 or so years plus, but they've been making them with heat ovens, and the heat ovens take a long time, and the cost is way up there. Okay, but now, more in the past 3 to 4 years, this newer technology is emerging, and it's because of nanotechnology. If you take a pound of copper and half a pound of copper, they melt at the same temperature. Or a pound of copper and an ounce of copper, they melt at the exact same temperature. But if you take that copper and shrink it down to a nanoparticle, it now melts at a very low temperature. So this allows them to make ink out of it, and the pulsing light transfers the ink to a sintered state where it becomes a solid circuit.
So you shrink it down to one layer. How small does it get?
Well, the nanoparticles are so small you can't see them.
So nano.
Nano.
This is nanotechnology.
Nanotechnology. And that's what makes the whole thing possible.
This is nanotechnology being mass produced.
Exactly.
And what are you showing here on the wall?
Very good question. This is our worldwide test network, where we have locations set up with equipment all over the world where people can go in and run tests. So someone in Asia does not have to FedEx a package to the U.S. to have a test run. They go right to the location in Asia, China, Singapore, Taiwan, wherever it happens to be. It simplifies the whole process.
So what do they do in the test?
Well, they want to make sure the process works. They want to make sure the ink they're using and the substrate using will make the circuit that they want to make.
They test out the designs of the circuits.
Exactly.
And the materials that they also design.
Yes. The process development.
But how many designs does your pulse lights work with? How many materials?
It's universal. Light is universal. And there are many, many ink manufacturers, many substrate manufacturers. There's ink of gold, copper, silver, aluminum, lots of different types of ink that have different formulations.
So people can print gold, silver, platinum,
right,
carbon,
right.
And what's the limit? Which one is good and bad? It depends on which one is good, right?
The holy grail really in this industry is copper, because copper will ultimately be the cheapest compared to silver or gold. And copper is the next evolution of the process.
So we want to print out millions of
trillions,
trillions, but millions a day out of one plant.
Right. One production line.
One production line could print millions in one day.
Right.
Copper-based, very cheap electronics.
Right. And this will include transistors, for example.
So what more do you show here?
Is
this stuff you do?
Yes. This is our equipment. It's called sintering tools. These generate the pulsed energy, the high-speed lightning bolts, for example, that actually sinter the ink and takes it from a liquid to a solid. So just imagine putting a trace of ink on a film and it's liquid, and then we sinter it and it becomes a piece of wire. And that's what it does. But it gets infinitely more complex than that.
It gets more complex.
Yeah, because instead of just a wire, now you can make a transistor or a circuit.
All right. What is that?
They put the samples in and run them through. And this is another sintering tool here, one of the most advanced sintering tools.
The most advanced sintering tools.
Use it to do very thick copper, which is what everybody wants. And the copper will be the holy grail of this print electronic market.
So what kind of conversations do you have here every day, today?
Customers wanting to know when inks are working, what substrates are working. Of course, what's the price of the equipment, how fast they can get it. Very good questions are coming up today.
And they want to get things done?
Yeah. There's a huge amount of interest. We have 100 of these machines worldwide. People are using it for process development, but more and more people now are saying we want to now go into the production.
They want to mass produce trillions of things.
Right.
As soon as possible. How soon?
Like yesterday.
Yesterday, but how soon do you think it's going to happen?
Usually, generally on average, once we get an R&D tool out, it takes 6 months to a year before they start getting ready to fully define their process to begin to go into mass production.
So what do you think about the ID Tech X conference?
This is a great show, the best show ever, and we really appreciate the effort they put into making this such a great show.